Hello and welcome, I'm your Code Monkey. In this lecture we're going to replace our boarding capsule visual with a nice proper character mesh. Okay, so in the included assets project files, over here if we go inside the prefab visuals, we see a nice player visual. Let's position it inside the player game object, so let's drag it inside. Again, because we separate the logic and the visuals, this is going to be pretty easy. We don't need to modify the parent game object at all. We just drop the visual as a child, that's it. Also, again, very important, make sure the visual is over here on local position 000. Only the parent game object should move, the visual itself should never move. If you notice some weird positions as your player moves and rotates, always check to make sure that the child visual is on 000. Okay, so with this, let's delete the old capsule, delete it, okay. So here we have a pretty simple but really nice character visual. It's really just two spheres stacked on top of one another with a bunch of eyes. Very simple. For the visual itself, the material is using just a solid color. So here it is inside the assets material. You can see a bunch of player bodies with different colors. These different colors, they won't be used in the upcoming multiplayer video. Basically, each player will have a different color. Also, by the way, if you're a complete beginner, here's a quick lecture on materials. These are materials, and if we click select, we can see a bunch of stats related to that material. Basically, the materials have a shader and then a bunch of properties. Now, the shader is the actual code that runs on the graphics card that says how an object should be rendered. By default, you have a whole bunch of included shaders. We're using the universal render pipeline, so you should mostly be using the ones inside the URP. And by default, you probably want to be using the standard lit shader. Then, of course, you can also build your own custom shaders. One excellent tool for doing that is Shader Graph, which I have covered in detail in a previous video. It's a fully visual tool that you can use to make shaders without having to write any shader code. It's a great tool. I've also made a bunch of tutorials on all kinds of effects you can make, although right now we're not going to be using custom shaders. We're going to do that later on in the course, but for now we're going to stick with the default lit shader. So materials have a combination of shaders and the properties on that shader. For example, over here for the default lit shader, you can see that it has over here a base map, that it has a color field. This is what you can change to apply a different color to your player. Also, as to how you apply a material to an object. Over here on the player visual, you can see the objects are made up of a sphere. So this is the mesh and then the mesh render. This is the one that has the material. So both these are what stores the shape as well as the visual for the object. The mesh is just a 3D shape, but just by itself, the mesh filter doesn't actually render anything. So it needs a mesh render, which needs a material attached to it. So for example, over here on the hierarchy, let's right click on empty space and let's create a brand new cube just to see it. So yep, there you go. It does create an object. And as you can see, it has a mesh filter and a mesh render. Now to apply a different material, you can click on this little circle icon and it shows you all of the materials in that project. Alternatively, you can grab the material directly from the project window. So for example, the player body, just grab it and drop it in there. Or you can also drop the material over here on scene view. As you can see, as I mouse over different objects, it applies that material to a different object. Although note, that only works over here on scene view, it does not work on game view. So this basically sets the material over there on the object. Now, one more very important thing on materials. If you have multiple meshes only using the exact same material, and then you modify the material, it will change the visual on all meshes using that material. So for example, if I modify the color here, put it on something different, there you go, all three instances, all three objects that are all using the exact same material, they all update with a new color. If for example, you wanted the head to be a different color from the rest, then you would just create a new material. So you can right click on the project window, let's create a new material, then you can give it a name, give it colors, use a different shade or whatever, and then use this one for something different. So that's pretty much the basics for materials. And by the way, if you're a complete beginner and you have questions, remember to post them in the comments and I'll do my best to help. Like I said, I want to keep this video moving. I'm trying to teach as much as possible while still keeping the video a reasonable length. So if you need any further clarification on anything specific, just go ahead and ask in the comments. Okay, so with the materials out of the way, here we have our player with visual. Let's just get rid of our cube, okay? And just with this, if we test, and yep, over here we already have a nice player visual walking around. Okay, great. Except the player isn't actually rotating. Ideally, the visual should be facing the walking direction. So if I walk down, it should be rotated to face down. So let's add that. Doing that is actually going to be pretty simple. Let's go into our script. Here we are on the player script. And over here, we already have the movement direction. So we're going to use this in order to make sure to rotate the game object to face this move direction. And for rotating a transform, there are many ways to do it. One obvious one is to modify the transform.rotation. However, this one, as you can see, works with quaternions. For me, even though I've been doing game dev for over 10 years, I still find quaternions quite a bit confusing, so I normally don't use this method. Another method is to modify the transform.Euler angles. This one is much more intuitive and makes more sense to me. It works with regular Euler angles, which is much easier to understand. If you don't know that name, it really just means the angles that go from 0 to 360. Then for another method, you can also use the function transform.lookat. This one makes the transform look at a certain point, so it can be a transform target, can be a vector 3 for one position, anything like that. So this is a very useful function. We could calculate a point right in front of our move direction and look at it. Or finally, the method that I personally like to use for this specific purpose, which is just modify the transform.forward. This one has the normalized vector representing the forward axis, and importantly, you can get it and you can also set it, so you have both read and write. You can read it to get the current transform forward, but you can also write to it to essentially rotate the transform. So we can just assign this to our forward vector. Also, by the way, you also have transform.up and transform.right. Both these work exactly the same way. For example, transform.right, this one is extremely useful for 2D games, but over here we're working in 3D, so we want transform.forward, and all we need is the forward vector, which is really just the move direction. So let's set this one equals the move there. Okay, so just like this, it should already work. Let's also just clean up the log. We no longer need to see the delta time. Okay, so let's see like this. Okay, here we are, and as I move, and yep, there you go, and look at that. The player object does indeed rotate to face the move direction. Okay, so it's already looking great. All right, awesome. However, it also looks a bit odd with how it's instant. So I move left and right, look at that, it instantly rotates. So there's no smoothing, nothing, it's way too janky. So let's add some nice simple smoothing. And for that, let's use a really awesome, really useful math function called lerp. It helps you interpolate between two values. I made a quick video showcasing a bunch of uses for it. You can lerp floats, vector 3s, quaternions, or just about anything. It's really perfect for making some smooth movement or smooth rotation. So for that, we can access the function inside the vector 3 class. So we can find lerp. Then here we actually have two options. We've got lerp. This one interpolates, and we've got slurp. This one interpolates, but with a spherical interpolation. Basically, if you're dealing with rotations, like what we have here, then we want to be using slurp. Whereas if you're dealing with just positions, then you want to use lerp. So here, let's use slurp. This one, as you can see, takes an A, a B, and a T. Like I said, this interpolates between A and B based on T. So for example, if T is 0, then it will return the value A. If T is 1, then it will return the value B. If T is 0.5, then it will return the point in between A and B. If you want to learn some more about interpolation and the math behind this, then I highly recommend you look at my video on splines. Splines are basically just a whole bunch of lerps put together. So anyways, over here we can add some smoothing to our rotation by just using the current transform.forward as our A. Then for the B, this one is our target, so let's use the move there. And finally for T, let's use time.delta-time. Meaning that with this, over time the character will rotate towards our target movement direction. So just with this, let's test. So here if I move to the right, and yep, look at that, it is indeed rotating. It's way too slow, but yep, it is rotating smoothly. Alright, so let's just add a bit more speed. So over here, let's just find a float for the rotate speed. Let's put it at something like 10f. Then we just multiply it, so time.delta-time multiplied by our speed. Let's see. And move, and yep, there you go, look at that, much, much better. Okay, great. So as you can see, everything works. As I move, the character does rotate to face the move direction. Alright, great. So here we have our character with a nice visual, all rotating to face the move direction. Now the next step is we want to add some nice animations, so let's do that in the next lecture.